The Indian Association of Structural Engineers, also known as IS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IS-Struct-E is registered under the Societies Registration Act 21 of 1860. IS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IS-Struct-E has collaboration with various international professional like-minded associations and institutions. IS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IS-Struct-E's activities are widely appreciated and known for quality technical contents. IS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IS-Struct-E's publications are becoming popular with time. IS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IA Struct E is available on its website www.iastruct.co.in.
Hello. Vikas, shall I proceed? Mr. Vikas,
Yes,
shall
sir.
I
Yes, sir.
proceed?
Yes, sir. Yes, sir.
Okay, my voice is audible? My voice
Yes,
is
sir.
audible?
Yes, sir.
Okay. Dear friends, welcome to the webinar. Today's topic is assessment and repairs of jetty structures for enhancement of load carrying capacities. We are grateful to Dr. Deshpande, who has been able to spare his valuable time to share his knowledge and experience. Brief profile of the speaker. Professor Dr. Yogini Deshpande is a distinguished researcher, entrepreneur, and educator, currently serving as the technical director of Renuka Consultants. She holds a PhD in civil engineering from Purdue University. Dr. Deshpande has previously held faculty positions in Michigan Technological University and the University of South Alabama, United States of America. Recently, she was appointed chair professor in the Department of Civil Engineering at O.P. Jindal University, while continuing her role at Renuka Consultants. In 2023, she was induced in the Daughters of Soil list of Indo Geotechnical Society. She currently serves as the honorary secretary of the Indian chapter of the American Concrete Institute and is on the board of directors of the Indian Concrete Institute, Mumbai chapter. Additionally, she is actually involved with the Women in Deep Foundations Institute, India, promoting the role of women in the field. Brief of the topic of our today's webinar is this presentation delves into advanced investigation and analysis methods for maritime structures aimed at enhancing their load-bearing capacities. Special topic include in-depth corrosion assessment for steel and concrete, fatigue life, prediction through instrumentation and monitoring, and specialized dynamic testing of dogs for concrete load rating and repair design. Through these specialized approaches, actionable insights could be gained to inform capital expenditure planning, optimize asset longevity, and reinforce jetty structures against increasing operational demands. Real-world projects examples will be presented here by her, illustrating how these techniques contribute to comprehensive asset management and sustainable infrastructure development in the maritime structures. Now, I hand over the table to the speaker. Madam, please continue.
Good evening, everybody. Thank you for joining today. And thank you to the Indian Association of Structural Engineers for inviting me for this presentation. Coincidentally, I just recollected it's almost 10 years, a decade ago, that I had presented at a conference of the IA Structure in New Delhi. in, I think, November itself in 2014. So almost a decade later, I'm getting this opportunity again to present for the members of the I structure. Today, I am going to be talking about how to do assessments of Jetty structures, specifically from understanding of what is the structural health as of today. How do we, what are the different types of tests that can be done, routine tests, as well as some in-depth analysis. And also then look at what are the kind of repairs that possibly can be done, and what are the steps that one would need to take if we want to enhance the load carrying capacities or just repair the structures. How do we arrive at the decision to just repair or to enhance, be able to enhance, or how long after enhancement would a structure survive? Some of these aspects I will be discussing through the presentation. A quick this about what Renuka Consultants is. We are basically an asset, an assessment providing consulting company. Our fundamental USP is providing assessments to the structures, be it underground or above ground. So we have a geotechnical or ground engineering services where we undertake all kinds of ground engineering problems and investigations, including pile testing, dynamic testing, thermal integrity testing, etc. Under the structural services, we primarily provide services for assessment of in-service structures of various kinds, from buildings, bridges to water treatment plants and jetties. And both these verticals are sort of the foundation for these services. A material assessment center that we have in Mumbai, Taloja, a massive a laboratory spread over 10,000 square feet, where we undertake various kinds of testing that are required for the civil engineering construction industry. Now, coming to the main presentation of today, structural assessment is typically divided into two aspects: a qualitative assessment and a quantitative assessment. Qualitative assessment is a very level zero basic assessment, which is mostly experience-based subjective assessment of the deterioration, the effects, and other damage visual inspection that is being conducted. That's typically conducted by visual inspection, maybe some light hammering on the structure. A quantitative assessment is a more measurement-based assessment. And within the quantitative assessment also, we can have two aspects where you have a routine measurement-based assessment, which is done in terms of assessment of the direct serviceability values measured from the load effects, which is like doing a rebound hammer or UPV or something like that. And a more model-based assessment is where we are looking at the safety and the serviceability of the structure. And starting from just assessment of the safety and serviceability based on the documentation data that is available, to going to a more refined approach where we do very detailed analysis, specifically in terms of corrosion studies, as well as load carrying capacities. Sort of initially develop what are the inbuilt drawings, go back, keep going back to the drawing board every time more information is provided, and on that basis understand what would be the effect and the extent of repair that could be possible for a particular structure. Now, the assessment is something which is of a structure. It needs a very holistic approach. Now, the client needs are something which are very important. The economic aspects: what is the amount of budgeting the client has been able to provide? What are the future needs of the client that they are looking at, for which the assessment is being done? So typically, in the assessment process, you need to understand what are the environmental factors affecting the structure. What are the technical factors the economic factors and the functional factors, and make a judicious decision based on each of these factors together. When the asset is created, when it is built, it is built for a certain expected life. Now, what happens is, when the survey is typically conducted when the problems are discovered. And once the problems are discovered, now we understand that there is going to be a shortening of the life of the expected life of the structure. And there is a depreciation in the value of the asset in itself. Now, the question then is, what is the cost to repair that deterioration, and what will be the extent of the life that is going to be increased? What is based on when the deterioration has become, based on what type of repair is going to be conducted, there is going to be probably an improvement in the service life, or there is going to be just a improved improvement in the extension of the service life in itself also. So the extent, whatever was the expected service life, it is being extended to a larger extent. Also, because of the repairs, there is an increase in the asset value in itself also that needs to be considered when you're doing the repairs. So, from the strategic asset management perspective, the decision support system needs is going to be based on what are the capital expenditures that are going to be done. Is it going to be for functional characteristics? Let us, in case of a jetty, whatever is its load carrying capacity as of today, is it going to be able to be carried tomorrow in itself also? What is the asset condition assessment as of today? What is it able to do, able to carry lesser loads even in today? So what is the operational performance able to do for what has been designed or currently doing at lesser capacities than what is designed at? And then the rehabilitation of the modification recommendation, whatever the modifications are going to be, what are the recommendation or the cost of it? And once the cost has been realized, what will be the cost? Is it going to be that the asset value is going to be realized and it's going to be a revenue increase for the owner in itself? And in all of this, what are the risks? Are we able to do the repairs? During the repairs, what are the risks involved? How much is the downtime? Given that downtime, what is the risk involved in terms of loss of revenue? All of these aspects need to be considered, specifically for large infrastructures like jetties. So in such cases, then, the complete rehabilitation process or the assessment process that will be undertaken has to be a very data-driven process. It cannot be a subjective visual inspection analysis and only. For every step that we are undertaking in terms of assessment, it is a very data-driven process. Because the owner is expecting certain answers in terms of, what is the condition of the asset? Does it need repairs? If so, when? Do we need to replace it, or we can repair it only? Or is it okay not to do anything and expect a gradual loss of performance in about 10 years or 20 years, whatever is it? And the last one could be that can we add additional loading to the existing condition given the existing condition of the jetty? Now, the environmental factors that need to be considered in case of jetties specifically is the splash zone. Typically, the major changes in the jetty structure in terms of deterioration are observed in the tidal and the splash zone. The infrastructure which is exposed to the atmospheric does undergo some amount of corrosion, but in many times it's been observed it's not extensively as much as it is observed, which is for splash in the tidal zone. In the immersive type of structure, portion of the structure also, the corrosion is not as much extensive as what is the microbiological degradation of the concrete that could be happening. So, typically, what we do is adopt a holistic approach for the assessment of the jetties. One aspect is the functionality of the structure, and the second is the durability of the structure. In terms of understanding what is the functionality of the structure, we adopt the first step is to do the visual observations and mapping, then assessment for current strength by field and some lab tests, preparation of drawings as per the current structure, specifically where such drawings are not available, if not available, analysis through software modeling for future loads, if that is what is expected from the client. In terms of durability, we want to look at the assessment of durability characteristics, specifically in terms of what is the cover, what is the chloride ingress, the level of chloride ingress currently in the structure, as well as what would be the chloride ingress in the future. And that field and lab test to determine this corrosion assessment, the current chloride present, the rate of chloride penetration. So, apart from the visual observation that needs to be done extensively, and I'll be talking about in the next few slides, testing has to be done extensively, and it is done sort of typically in two parts. One is the usual this, where you're looking at the quality of the concrete by way of ultrasonic pulse velocity, carbonation, which effectively is giving you what is the extent of the chemical changes that is happening, the rebound hammer test, in situ core strengths to give you the understanding of what the core strength is, and also extraction of cores for chloride penetration, chloride diffusion, and chloride permeability aspects. From the structural assessment perspective, you can opt for seismic tomography, specifically for masonry structures, to determine the localized failures, if there are any. Reinforcement mapping to see if the current drawings are the structure drawings are available, if the current structure is as per the drawings that are available, or if there have been changes that have taken place. And impact echo test to understand, if possible, the pile length and the pile quality. Now, in terms of when we opt for the visual observations, it is necessary to develop certain scales based on what the structure is, for a rapid assessment, to be able to do a rapid assessment. So you can develop scales for the concrete structural elements based on what the condition is, with one being that it's a new element or there is no visible defects and damage. Second is somewhat as new, but there are certain hairline cracks which could be less than 0.1 mm. There's some minor efflorescence happening, maybe some amount of damage or leakage to a certain extent, and progressively then go from 1, 2, 3, 4, 5 to 7, where there is an extensive severe concrete spalling with exposed reinforcement and reinforcement loss of more than sectional loss of more than 20%, in which case the component will typically fail extensively. Collect the evidence, gather this evidence in terms of photographic evidence. Now, in case of jetties, like I mentioned earlier, we're looking at each structural element separately. We have developed scales for each structural element. So in case of piers, we have said there will be 3 scales. Scale 0 is a pier with no damage and as good as newly constructed sort of a structure. Scale 1 would be showing scaling of concrete to certain general surface deterioration. Some amount of mortar has been washed away due to continued exposure to seawater. Typically, this is again observed more in the tidal zone or the splash zone than the length of the pile, which is below the tidal zone. Scale 2 is showing scaling of concrete and general surface deterioration, some amount of corrosion, exposure of the reinforcement, specifically in the upper zone. Scale 3 is piers showing scaling of concrete and general surface deterioration, which is more than 50%. Reinforcement extensively exposed and concrete spalling is observed. In case of masonry docks, we also adopt for a visual inspection in terms of using cameras to do a visual observation within the joints, to try and get some information about it, specifically docks which have been more than 50 years old. The joints, the jointing can be extensively damaged, and this kind of photography gives us an understanding of what is the depth of those drawing damages, and what if there is a large amount of scaling that has happened inside. Another important structures that are observed in jetties are the bollards. And bollards play a crucial role, specifically in terms of carrying the loads, and they are and the tensile loads that are applied to it. So we looked at the bollards also typically in great clarity in terms of how is the foundation of the bollard, how is the concrete section, if is it attached to the pile cap or the beam below, if yes, how is the attachment, are the bolts exposed, rusted. So all of these aspects are extensively visual observation is done and photographed and mentioned in the this itself. Once this distress mapping has been conducted, there is the distress mapping is then reflected on the drawings in itself. This gives again for the client as well as for us for the further analysis a proper picture of what is happening at each section of the jetty, and where there certain sections might be having maybe more extensively damaged than compared to the other sections. Then the next step is to understand what is the reinforcement mapping. If specifically if the drawings are not available, then extensive measure reinforcement mapping needs to be done. If the drawings are available, then at least just checking to ensure that whatever drawings are available, the same reinforcement is being observed on the deck in itself. In terms of for masonry docks, typically these masonry docks have the crane trail tracks running on the middle portion and the docks being on the other side. Now, specifically in those where they want to look at enhancing the capacity of these cranes, it is necessary to understand what is the load carrying capacity of this portion, the filled up portion of the dock. In case over here, what we had adopted to do was use seismic refraction tomography. In this, we used the seismic refraction tomography at 24-channel geode seismograph and applied a force, a vibratory force from a striking plate from one end. Geophones were attached on the two ends. Geophones were attached on the two ends of the masonry walls to capture the vibrations. And once these vibrations were captured, we were able to plot it and understand the cross section. Excuse me. Specifically, if there are any weak planes or weak zones along the depth of the complete field area. So this is the depth of the field area, and this is the this of it. So other than the earlier tests were mentioned, I said routine tests were also done, which is the hammer test, the UPV. Core extraction was done specifically to understand what is the level of carbonation that has happened. All these tests were done on the trail track as well as beneath the rail track, crane track, wherever possible. And the values were then plotted. Specifically, the hammer test was plotted versus what is the actual average core strength that was received. This information was important when we were doing the analysis, the structural analysis of the jetties afterwards. Pile length assessments were also conducted for RC jetties using impact echo testing. Now, in-depth corrosion assessment is done. Primarily, the common objective for the understanding is how long will a jetty be able to remain in a pristine stage or if it is already in a deteriorated condition, how long will it continue to be in this stage before it fails? And if it is going to fail, how quickly do we need to fix it, and what is the extent to which we need to fix it to be able to bring it to the current carrying capacities? Now, in reinforced concrete corrosion, there is a certain initial stage at which the corrosion starts. Now, this corrosion starts typically either because there is a chloride ingress or there is an exposure to carbonation. From the time that the corrosion is initiated, and initially there is a chloride ingress happens, that is, chloride is able to reach up to the reinforcement in itself, and after which there is a corrosion products start building up. Once the corrosion products create as a very high stress, then further corrosion reflects in surface cracks happening and strains happening on the concrete in itself. Now, in concrete, you have three types of ingress mechanisms that are sort of the driving force for chloride corrosion. Typically, it's the absorption, which is based on a surface tension principle, and then you have the permeation, in which it is based on the pressure, that is the amount of chloride salts that are present on the this, and the last one is the diffusion, which creates a concentration gradation, and the property typically is termed as diffusion coefficient. Now, for marine environments, chloride ion ingress is primarily by diffusion, because it's like the front surface is exposed to maximum amount of chloride, and the inner surfaces is not exposed to as much chloride as the front or the outside surface. Now, tests for diffusion of chloride ions are typically the chloride bonding test, which is the ASTM-C 1543. The NT-built 443, the SMC 1556, the immersion in chloride solution and profile grinding. NT-built 492, which is the migration of the chloride using an applied electric field, and the ASTM-C 1202. The chloride, I am going to speak a little bit more detail in the chloride bonding test. In this test, what is done is that the specimen is cut. Now, if a specimen is cut from an existing structure, you remove the top 5 centimeters, and you take the specimen, whatever is remaining after that. It is sealed and kept in a 3% NaCl solution, after which there's a certain, before which there's a certain specimen preparation aspect that's done, and then it's kept sealed in the 3% NaCl solution. After 35 days, this specimen is then removed, and the specimen is cut in small pieces of 1 mm each, and from the top surface to up to about 20 mm. At each mm, the amount of chloride present is measured through a chemical analysis. So it's the actual amount of chloride that has been able to penetrate into the concrete surface is being measured over here. And this is then plotted as a chloride profile fit using the Fick's law. So what I was mentioning here is this is the core sample that we take, of which the top 5, what we had done was we used the top 5 centimeters of the export surface to understand what is the amount of current chloride present in the concrete in itself. After that, the remaining sample was taken for different tests. It could be RCPT, RCMT, or the NT-built. Each specific information of chlorides present either in the thin sample section that were taken out directly from the current condition, or done by the NT-built test. The chemical analysis, it gives an idea of what how the chloride concrete level is increasing, and how it is from the depth of the surface. This gives us the chloride profiles. and we're able to establish these chloride profiles for different elements. So it could be for the crane slab itself, or it could be for the piles in itself. Now, based on the concrete chloride levels at the increasing depth from the surface, we are able to correlate it with the risk of corrosion. If there is less amount of chlorides being present, obviously there is going to be less or negligible risk of corrosion. As the amount of chloride levels go on increasing, the risk to corrosion goes on increasing. Then, based on the amount of the chloride diffusion that we are able to have, the chloride profiles of the threshold that we are determined, the carbonation levels that are there, we are able to create probability graphs for what should be the concrete cover, what should be the carbonation depth, and what should be the surface concentration based on the diffusion of the chlorides that we have conducted. All of this information put together, also the information that is received by the visual observations, where we had different scales, we are able to create a certain criteria where we say if the corrosion related damage of each element, so the percentage of elements of surface area, how much it is, and if we decide at the end of life cycle the structure cannot survive more than 10 years or 20 years, 30 years, we can decide when the timing of the repair has to be done and how much it will be able to extend the service life based on that. This gives us a good tool to decide what and when repairs can be taken. So once we are able to take that decision, okay, repair has to be done. Now the next question then is, how much is going to be the increase in capacities, and how do we arrive at that ability? What are the steps we need to take to have to decide what is the increase in capacity that we can adopt for? So if you look at the slide I presented earlier, as we've gone through the first functionality of structures, we've gone to number one, which is the visual observations and mapping, assessments for the current field and lab strength of by field and lab test. We've done the preparation of drawings also. On the other side, we've done the assessment of durability characteristics, looked at what are the different in-depth field and lab tests to determine the corrosion assessment, and what's the current chloride presence, rate of chloride penetration. So then we look at what is the load carrying capacities. We carry out the design of the jetties in somewhat very much similar way as what we would do if it's a new construction for the design capacity, but with whatever the strengths of the structure are as of today. So if it is less than what is the designed concrete strength, we take it as less than design concrete strength. If it is, so that we take those values that have been achieved at on average values from the field and the lab test, use those values to look at what is the design and where are the deficient moments that are coming. That is, when we look at the visual nature of the structure, we realize that in some places the structure may not be performing well, or currently may be performing for certain reasons, but if the load is increased, or if the load is even used at what it is supposed to be designed for, there could be a chance of failure. If we then look at, if we want to increase the capacities or maybe increase the field loads without doing any repairs, what would be the condition? With doing the repairs, and the extent of repairs being that we improve the strength to a certain extent, we improve the reinforcement to a certain extent, what would be the structural enhancement that can be done? What needs to be understood and remembered in these iterations that we conduct is that any repairs that we may do by providing carbon fiber wrapping or newer steel, there is just a certain extent that we are able to do it. We cannot assume, or even if it may be showing us from the analytical way, that a complete enhancement of the load carrying capacity is possible. So in the sense that if we have a fracture in a hand, today the doctors insert a steel or a rod in the hand, and they rehabilitate the hand with the azam. But for I'm sure many of you are aware that eventually, even after that, a person is not able to utilize his hand completely. So that understanding has to be there of what is the extent of enhancement that we are able to adopt. Is that enhancement going to be more over and above what what the current capacities are, or is it going to be just maybe a little more than the current capacities? This understanding has to be arrived at methodology. Typically, the repair schemes include application of new reinforcement, providing of microconcrete wherever necessary, and then providing of CFRP laminates, whichever. So in the jetties with the drawing that I had shown earlier, where there was an extensive damage to the piles and the pile head over there, we had proposed carbon fiber reinforcement carbon fiber reinforced laminates along the complete length, so that the enhancement can be achieved. What we provided to the this was that you are able to have a condition assessment state that goes from 1 to 7, 7 being the worst, 1 being the best, and what could be the expected remaining life if the repairs are done as suggested, and if the repairs are not done as suggested. Both these aspects were provided to the clients. And typically, executive summary was provided, which mentioned what are the defects currently present, for which affect the long-term durability, minor deterioration that can be avoided by doing coating or parent material adjustments. And then what would be the expected life if the repairs is done? If the preventive repairs are done, how can the crane capacities be enhanced? What would be the extent to which they can be enhanced? So these are typically the summary of designs, which is the members which are adequate, members which are inadequate, that were provided to them based on the different wheel loading. So we opted for different types of loadings that could be adopted. Then the repair strategies were typically in two ways. One was the functional requirements, which were improving the structural capacity by provision of fiber wrapping and steel replacement for piles. For beams and slabs, structural steel was added. Required capacities, if not reached, then changes in loads or pitches were provided, which would improve the load capacity in itself. Now, the selection of methodology was typically based on multiple aspects. One is the allowable downtime that the client can adopt for the repairs to be conducted. What is the extent of robustness of the repairs that the client is expected? And what is the interaction of the new material with the existing system in itself? And of course, obviously, the cost of the system. Durability requirements suggested the use of supplementary cementitious materials for the repair, removal of existing cover and increased cover for concrete for all structural elements, usage of repair systems to avoid reduced corrosion, which includes sacrificial anodes, corrosion inhibitors, etc., and robustness of repairs and interaction of new materials with existing system was always been observed. This was a typical analysis that was provided to the client. So from a conclusion perspective, the owners require robust information to take informed decisions. So for a long-term asset management, it is necessary to have a detailed starting point for health of the structure so that the owner is aware of what kind of decisions they need to take. Functional assessment is affected by structural strength as well as the deterioration mechanisms that are observed in the concrete. Thank you.
Thank you, ma'am, for excellent talk. Now I leave the floor to the audience for questions. Before that, Madam, I have one or two small doubts.
Yes,
Just
sir.
tell me something about seismic tomography and then instrumentation with respect to structural health. Just tell something about that, please.
Okay. So seismic tomography is actually normally done for ground engineering, and so we used the technology or the science of it for this particular structure, primarily because I'll just go back and share. Okay, so in over here, this is a dock and this is a crane trail. Now, what the client wanted was to understand what is the stability of this crane trail, because this dock has been built many years ago and they have no available information. Some amount of leakage has been observed from the joints of the masonry structure. So, to have a better understanding of the filling in a two-dimensional way, what we did was we adopted this technology for a concrete then the crane trail is obviously nothing but a concrete pavement on a stabilized or spilling. So we adopted a seismic refraction tomography for it, and in this what is done is geophones are placed along the length. So in this case, the geophones were placed along this height over here. And there was a vibrating plate over here that was, a plate was placed over here, and the strike plate was struck with a hammer of a known weight, and this created vibrations which were picked by the geophones, and the signal was sent to a seismograph, which is basically a data logger system. And from there, it went to a data logger, it collected the data. We did the analysis of the data that was collected to understand. So basically, this is the crane trail. This is where the seismographs were on the two ends that they were attached. And we were able to get if this was still very well dense system or not. And if it would be able to carry the additional crane loads if necessary.
Thank you, ma'am. Other question was instrumentation with respect to structural monitoring of Jetty.
I have not covered structural and monitoring in this particular, so I'd like to not, you know.
Right. Then we'll invite you next time to talk about the subject. Now, other listeners, please ask the question. Vikas, please help.
Yeah, sir. Yeah, ma'am. There is a question by Miss Vidya. How are these tests different for river jetties as compared to sea jetties? Sea
jetties.
As compared to sea jetties, given the salinity of the water.
Yeah, so the test will not be different. Maybe if the river water is not very saline, then the focus would be on the water absorption itself only, because water absorption also creates corrosion headache. So over there, the test or the parameter that we are looking at would be different.
Thank you, ma'am. There is another question by Mr. Mohammed. We didn't discuss the lateral stability check of the jetty structure. Will this be not part of this study?
Lateral stability. Yeah, so we did for the lateral stability, like I mentioned, we also did the analysis of the bollard. So visual, I did mention the extensive bollard visual testing that we did. We did the steel testing of the bollards also, and we did a bollard pull test that would give information. Now again, see, this depends upon where the jetty is located, what are the forces, different forces that are acting on it. So if it is located in inside waters or calmer waters, or if it's located in more right in the sea kind of thing, so there based on where it is located, the impact of different types of loads will take important.
Yes, sir, these are the only questions we have.
Okay.
Madam,
Ma'am, one
on
second.
behalf
There is one
of-
question. Yeah.
please continue.
Yes, sir, there is a question. One question in the chat box by Premanand Shinoy. By conducting test on a single date, how do we access the life? You apply any assumed deterioration curve. Will it be same for all components? ये first question है उनका. Then second question, if you conduct strength of concrete, the location of test will be importance, or you consider the lowest strength for all.
Okay, I got it.
Locations.
Yeah. So by conducting tests on a single date, no, that's what I said. There are 3-4 different types of chloride ingress tests that are conducted. Now, obviously, we have one is we are looking at the chloride profile for what is the chloride ingress as of today, but we are also conducting another test to understand the chloride diffusion, in which the sample is subjected to 35 days of chloride immersion. So some understanding and a probabilistic way to excuse me, to infer what could happen in the future is obvious, is being integrated into the system of our assessment. That is the thing. Now, if you conduct strength of concrete at the location, so strength of concrete is done at various locations above, so on the crane trail as well as below, on the piers and everything. And the strengths are in the analysis, the structural analysis, when it's done, the strengths are assumed for that particular structure. So for the crane trail, it would be based on an average of the number of tests that are done on the crane trail. For the piers or the pier caps, it would be based on the strengths that were observed on those locations. So it's not like the bottom is considered for top or top is considered for bottom.
So any more questions?
Yeah, sir. One more is received. Any
please,
recent, Miss Vidya asked, any recent example that you can provide where life of the asset was extended due to timely tests done? What recommendation you give to the clients about periodicity of these tests?
Any recent
example that you can provide where life of the asset was extended due to timely tests done?
Oh, yes, I could. I mean, I can't provide it that way because there's a this from our client we can't mention the name or the location, but obviously
In general,
in general it will happen. It's not that it won't. Now, what recommendation you give to the clients about periodicity of these tests? So it would depend upon what is the current state. If the current state is such that first of all it needs immediate repairs, then once the repairs are done, then maybe every 5 years it should be done. But typically, while there is not much how should I say, any BIS standards or this as much extensively and from the Indian perspective as they are available in the some of the other nations. The Australian Jetty Ports and Jetties Association or they are typically asking to have periodic assessments done first after construction, maybe after 15 years, and then after every 5 years.
Yeah, ma'am,
no
there
more
is another
questions?
question. No, sir, one
please.
question. Is there any other technique other than low strain dynamic test to establish the toe level of pile? What about permanent sheet piles?
See, you could do parallel seismic tests to understand the depth of this. That's one also there. I don't know what your question is in terms of what is the permanent sheet piles, but the first one I answered.
Yes, sir, these are the only questions.
Madam, excellent presentation, and I am sure the persons who are listening to you got benefit because such things are never taught in the school or colleges. So on behalf of Institution of Structural Engineers and on my behalf, I thank you very much for sparing valuable time and sharing your experience on such an important topic. Thank you once again. God bless you.
Thank you for inviting me, and anybody can write to me. I've just put in my email address. If you have any questions or any doubts, you can definitely get in touch with me on my email. Thank you so much. Thank you for
Thank you,
inviting me.
madam. Thank you. Thank you very much.
Thank you, ma'am. Thank you, sir.